Section 6.1 is called the paired t-test and the two-sample t-tests. And so as the title suggests, we're actually going to have 3 hypothesis tests, each of which comes along with a confidence interval. So in this one section, we have 6 different inferential procedures. A few things to realize about this. One is that as we get a lot of procedures like this, it's going to become more and more important to think about them in the right way so that we can decide which is appropriate, right? We can't think of this as choosing 1 out of 6 procedures. We need to think of it as a few separate choices that combine to tell us which procedure we should do. The second thing that you should keep in mind with this section is it is a long section. We'll usually spend a bit more time on it. And in section 6.2, we'll continue to practice it. So it's not something that you're intended to learn all at once in like a single night. It's something that you should spend some time on. So the underlying idea of all of these procedures is that our goal is to compare 2 unknown means. Now, if we're going to compare 2 means, these have to be means of essentially the same variable, right? We can't compare apples and oranges, right? We need to be comparing means that are measured in the same units and are talking about the same sort of thing. And it turns out that there's 2 main ways to do this. And the first is what's known as, and it really comes down to how the data is collected. So we have paired data, and I'll just give you an example where this would show up. So let's say that the Boise State track team wants to compare 2 running shoes for their runners who are running the mile. So BSU track wants to choose between 2 shoes for 1 mile runners. And what they're going to try to figure out is which one has a faster average mile time. And of course, this is not something you can know for sure, right? Because even if you're not concerned with people who aren't on your team, you might think, oh, this is a small population. This isn't a statistical question. We're probably not really just talking about individual runners, but we're probably talking about all attempts at running the mile by individuals on the team. So it is, in fact, a large population, and it is, in fact, a question that we can't know for sure. How would you approach doing this? There's 2 options, but the best option would be to do an experiment where you select a group of runners and this group runs the mile in both shoes. Not like one on each foot, right? But they run the mile one day in one shoe and then run the mile the next day in another shoe. Or maybe there's more of a gap, if you want to make sure that the fact that they tried to run a mile fast isn't influencing the next attempt at it. And the idea here is that what you end up getting for your data set is that each runner has 2 times one in each shoe. So your data is paired. That is, you have 2 data sets. You have shoe A and you have shoe B, but the times aren't just kind of a collection of times that are unconnected to each other. If you have, if one person ran it in 4 minutes, 30 seconds in one shoe, you can also ask, well, how fast did they run it in the other shoe? So your data is paired together. And so this is the paired t-test. And the paired t confidence interval. That's what we would do when we have paired data. So that's one of the things we're going to look at. Again, I'm not going to describe how to do that in this video. I'm just kind of giving you a sense for what our goal is here. The other 2 procedures, the 2 sample t-tests, are when we have unpaired data. So one thing you may have noticed as we have worked through the workbook is that occasionally in previous sections, we have had experiments that were just not randomized experiments. And that may seem a bit weird, but what the explanation is that the procedures we've done so far don't really make sense for randomized experiments. To do a randomized experiment appropriately, you need these things from section 6.1. So an example of unpaired data, I'm going to modify a previous example where we had a non-randomized experiment. We have a question like, does some drug help with weight loss? So this is going to be an experiment. And in the example in section, I think 4.2, we just had an unrandomized experiment where every single participant took the drug and we measured their weight loss. But the problem with that is that you don't actually know or even expect that someone who wasn't taking the drug would just maintain their constant weight, right? Someone who's hoping to lose weight is likely doing things other than taking this drug. And so in a good experiment for this, you would have a treatment group that takes the drug for some specified period of time, and we would have a control group that doesn't take the drug. They take a placebo. And these are two means that we want to compare. So we compare these two means. That is, from the samples, we have an average weight loss from the treatment group, and we have an average weight loss from the control group. And again, as I mentioned before, this is not a thing that you can know for sure. We're not actually interested just in the specific people in the group. So even if the treatment group does a little bit better in terms of weight loss than the control group, we can't be definitively certain that it's due to taking the drug. And so we need to do a hypothesis test. I left off an S here. Compare these means. And this is unpaired data because we have two data sets. We have our treatment group data set, we have our control group data set, but there's no way to pair the numbers together. This is unpaired data. That is, it's not like we have someone in the control group and, their twin is in the treatment group. That's not how experiments work. We don't have a way of pairing these things together. And so in this situation, we would either do the two sample t-test for unequal variances, or we would do the pooled t-test. Now, as I said at the beginning of this video, this is a long section. We cover six procedures, right? We have three different underlying ideas, and we have a hypothesis test and a confidence interval for each. The goal of this section is mostly to teach you how to do the procedures. And so what I would say is when you're doing this section, that should be your main focus. If someone tells me, hey, do a paired t-test, do a paired t-confidence interval, how do you actually do it? Or if someone tells you to do a two sample t-test or a pooled t-confidence interval, how do I actually do that? The secondary, very important question of which procedure to choose if you're not told, again, important, but I would recommend not focusing on that too much in this section. The one thing that I do think you should start thinking about is this distinction between paired data and unpaired data, because this is a very fundamental distinction. That is, did you collect the data in such a way that numbers from the two data sets naturally appear in pairs, or do you have two separate samples that don't really pair up in any way? And so that's the thing you should focus on. The distinction between these two tests is somewhat technical, and I'll talk about it more, but that's something that we'll focus a little bit more on section 6.2. So remember, 6.2 is going to revisit all this stuff. We'll get a chance to practice it and focus more on when is each of these appropriate. So that's what 6.1 is. Again, it's a long section. I recommend starting it earlier rather than later. But in the end, if you have the right approach to it, I think that it won't feel like 6 different things. It'll feel like a few questions you have to ask. And then once you identify that, you can just go ahead and do the correct procedure.